Today, we're going to talk about something every single one of us does, but maybe without thinking about the massive impact it has. We're talking about choosing the right foundation for your containers. So, think about this for a second. That very first line in your Docker file, could it really be your biggest security risk? I mean, it seems so simple, right? Well, let's get right into it, because that from instruction, it's way more than just a starting point. It's a massive architectural decision that sets the stage for your security, your performance, everything. You know, a lot of the default base images out there make you pay what's called the bloat tax. It's this hidden cost, right? They cram in all this extra stuff, shells, package managers, you name it. And sure, it's kind of handy when you're developing. But in production, whoa, all those tools are basically a toolkit you're handing over to an attacker. Okay, let's start by looking at why. We'll dig into the most common choices, your Debians and Ubuntus, and uncover some of the hidden problems they bring along for the ride. This quote just nails it. That from instruction, it really is the bedrock of your whole software supply chain. Seriously, think about it. Every little vulnerability, every bit of inefficiency you inherit right there at the beginning, it just gets magnified, copied, and pasted across your entire system. It's a decision that just echoes. Wow, okay, look at this chart. This just lays it all out, doesn't it? A full Debian image is, over 125 megs? Even the slim version is still around 74. And then look at Alpine, 5. Just 5 megabytes. That's not just a small difference, that's a whole different universe. And this isn't just about saving a bit of disk space. This is all about attack surface. And that size difference leads directly to something called vulnerability noise. You get hundreds, maybe thousands of security alerts for code that your application doesn't even use. The real cost here is people's time. Your security team is just drowning in false positives, trying to triage alerts for stuff that doesn't matter, instead of hunting down the real threats. All right, so the answer seems pretty simple, right? Just grab the smallest image you can find. Which brings us to our next section, the allure of Alpine. But as we're about to see, is it a smaller image with a bigger problem? I mean, look at that number, 5 megabytes. It just feels perfect. You're thinking faster pulls from the registry, less storage, and a teeny tiny attack surface. It seems like the silver bullet we've all been looking for. On paper, it's a no-brainer. So, smaller is always better, right? But there's got to be a catch. And this is where things get really interesting. See, Alpine's tiny size isn't just because they deleted a bunch of packages. No, it comes from a really fundamental design choice, a choice that has some pretty big and often invisible trade-offs. Okay, so here's the deal. It all boils down to the C standard library. Most of the Linux world, your Debians, your Ubuntus, they use a library called glibc. It's big, it's feature-rich, it's the standard. Alpine, on the other hand, uses Muzzle. It's super lightweight, simple, and designed for security. But it's not 100% compatible. It's kind of like speaking a slightly different dialect. Most of the time it's fine, but every now and then it leads to some really weird, really hard to debug problems. And what kind of problems are we talking about? Well, you might see random DNS failures inside Kubernetes, where your app just can't find another service. Or if you're using something multi-threaded like a Java app, you could see performance just tank, like up to 4 times slower. And if you're a Python developer, it can be a real nightmare. You try to install a package and it fails because the precompiled version doesn't work with Muzzle. So you have to install a whole compiler toolchain, which completely defeats the purpose of using a tiny image in the first place. So if Alpine can be a bit of a trap, where do we go from here? What's the real path to being minimal and secure? Well, that brings us to the next step in the evolution, Distroless and Scratch. This is where Google's Distroless images come in. And honestly, they're a really clever idea. They're container images that have only your application and what it needs to run, nothing else. They take the compatible glibc from Debian so your code works as expected, and then they just remove everything else. No shell, no apt-get or APK, no extra tools at all. It's genius, because if an attacker breaks into your container, what can they do? There's nothing there for them to use. But what if you want to go even further, to the absolute extreme of minimalism? Well, for that, you can use from Scratch. Now, Scratch isn't an actual image. It's more like a keyword that tells Docker, start with nothing, a totally empty canvas. This is perfect for languages like Go or Rust, which can compile down to a single static binary. You just copy that one file in, and that's it. It is without a doubt the smallest attack surface you can possibly have. Now, using Scratch, it's definitely a pro move. It's not for the faint of heart. You have to be super intentional about it. For example, with Go, you have to use special build flags to make sure your binary is truly static with absolutely no dependencies. And then you're on the hook for everything else. Need CA certificates to talk to the internet? You have to copy those in yourself. It's powerful, but you're flying solo.
Okay, so picking a great base image is a huge first step, but it's just that, a first step. It's not a one-and-done thing. You need to have an automated guardian, always watching. So let's talk about tools and process.
So when it comes to scanning for vulnerabilities, not all tools are created equal. They actually have different philosophies. You've got Docker Scout, which is awesome for comparing what's changed between your new build and what's in production. Then there's Trivy, which is all about pure speed in your CI/CD pipeline. And Snyk is really focused on the developer, right? It tries to help you fix things, suggesting better base images, and even making pull requests for you. Different tools for different jobs. Okay, so scanning is great for finding problems inside your image. But what about protecting the image itself? What if someone tampers with it after it's built? That's a classic supply chain attack, and that's where image signing comes in. The old way was, well, complicated. The new way is much better, using tools like SigStore. It basically lets you put a digital signature on your image, proving that it came from you and hasn't been touched. It's a public, verifiable log that says, yep, this is the real deal. And this right here, this is maybe the most important practical tip. For true immutability, you have to pin your images using their SHA-256 digest. Not .latest, we all know that's bad, but not even a version tag like .1.2.3. Why? Because tags can be moved. The only thing that guarantees you have the exact same bits and bytes is the image's digest, its unique digital fingerprint. It's the only way to be 100% sure that what you tested is what you're running. End of story. All right. We've covered a lot of ground, so let's wrap this up and make it super practical. Let's build your personalized playbook, because there isn't one single best image for everyone. The right answer really depends on what you're doing. So let's look at a few common scenarios. First up, the Enterprise Java and Spring Architect. My recommendation, just don't use Alpine. Please. The JVM does some pretty complex stuff with memory and threads, and it's just not a good match for Muzzle. You're risking weird stability and performance issues in production. Stick with something proven and glycine-based like Eclipse to Murin. You need that rock-solid compatibility. Next, what if you're a Python or Node.js microservice lead? Again, I'd say avoid Alpine. You'll just end up in a world of pain trying to compile native extensions from source, and your image will get bloated anyway. The better path here is to use something like Debian Slim for development, and then for production, go with Google Distroless. You get the security wins without the compatibility headaches. And last but not least, for all you systems programmers out there writing Go or Rust, you get to have all the fun. My recommendation? Go for it. Use from scratch. Your code is a perfect fit. You can build that one single static binary that has everything it needs. It's the absolute minimum attack surface you can get. There is no operating system to exploit. There is only your code. So as we see our images get smaller and smaller, and our supply chains get more and more automated and secure, it begs the question, what's the next frontier? I think the direction is pretty clear. We're moving away from these big, general-purpose operating systems in a box. The future is all about purpose-built, minimal, and verifiable artifacts. It's about shifting security from being something you check at the end to being a fundamental piece of the architecture from the very beginning.